Cancer risk evolution using a 5-dimensional radar, model and topological geometry, number 1384, VMT Sharp 721, TDA Sharp 005, October 8, 2025. Gerald C. EclaireMD Foundation. Category, Cancer and TDA Methodology. Mission statement: I write these medical papers not for fame or recognition, since I have already lived a long and successful life, though not always a healthy one. My purpose now is to share what I have learned about health, disease, and medicine, so that others can better understand their own conditions, prevent illness, and live longer, healthier lives. Introduction. Over the past 16 years, I have developed and refined the Viscoplastic Medicine Theory, VMT, a physics-based viscoplastic energy model that quantifies human health through dynamic stress-strain relationships. Recently, I have introduced a mathematics-based framework, based on topological data analysis, TDA, to describe the geometric continuity and connectivity of health data. While VMT measures how much energy changes, topology describes how the shape of the system and connectivity of data points changes. Together, these two different frameworks allow me to visualize human metabolic evolution and progression of diseases not as isolated numerical points, but as living physical energy and mathematical geometry forms. Methods and data. In this study, I examined 18 biannual periods, i.e., 36 years, from 1990 to 2025, period of longitudinal data involving 1 output strain, cancer risk, and 5 input stressors, obesity, type 2 diabetes, T2D, health age, diet, and stress and sleep score, S&S. Each of these input stressors was normalized between 0.0 and 3.0 for 18 biannual comparison. A radar chart itself is not a mathematical theory, but rather a mathematical visualization or measurement tool, a geometry-based plotting method. I used radar charts to construct 5-dimensional geometric profiles for 3 specific representative periods, from Y90 to Y91, from Y12 to Y13, and from Y24 to Y25. Each polygon represents one health state, the influential factors of my cancer risk. When stacked together, these radar charts form a 3D radar tube, symbolizing the system's viscoplastic strain evolution over time. See attached figure. By the way, Japanese media, business presentations, and even academic materials frequently use radar charts, often called Reda Chato or Kumo no Sugurafu, because they fit several cultural and practical preferences in Japanese communication. Results and observations. In from Y90 to Y91, the radar polygon was large, and dominated by high T2D and diet values. By the way, diabetes and diet, both quality and quantity of meals, are highly corrected. This early phase, from 90 to 91, represents one of my worst health state during the past 3.5 decades, with maximal internal strain energy and heavy cumulative metabolic stress. By from Y12 to Y13, the radar shape had contracted significantly. All 5 stressors decreased, particularly T2D and diet. The polygon became more balanced and symmetrical, indicating improved system stability and partial release of accumulated viscoplastic energy. From my VMT energy calculations, by from Y24 to Y25, the radar shape became the smallest during the last 3.5 decades, and most uniform, indicating that all 5 stressors had reached similarly balanced and stable. Each axis approached near normal values, representing a stable and low energy state. This stage signifies a nearly complete recovery and equilibrium between metabolic inputs and biological strain output, for this case of my cancer risk. When viewed together, the 3 radar charts display a clear and continuous shrinkage sequence. From Y90 to Y91, high strain; from Y12 to Y13, medium strain; from Y24 to Y25, low strain. This geometric contraction perfectly parallels the VMT energy curve of cumulative stress reduction, confirming that the radar geometry can faithfully reflect viscoplastic energy relaxation. See my paper number 1372. Discussion. The radar chart, when interpreted longitudinally, becomes more than a static 2D plot. It is a cross-section of a multidimensional health manifold. Each polygon corresponds to one temporal slice, while the collective shape over time represents a continuous geometric surface. Within a 6-dimensional functional space, 5 stressors, 1 strain output. In this higher dimensional space, smooth transitions between polygons correspond to gradual energy dissipation and recovery, whereas abrupt shape deformations indicate bifurcations, points, where the system splits into 2 different paths or outcomes, often triggered by pathological events. From a physical perspective, the contraction of the polygonal area implies decreasing viscoplastic strain energy, similar to how a stressed material gradually returns toward its original shape once the load is removed. From a topological perspective, the continuity among these shapes suggests that my metabolic system followed a smooth, non-chaotic recovery trajectory with no major structural discontinuities. Significance: this interpretation of radar charts geometry transforms traditional biomedical data into a dynamic visual tool of human health. It bridges the quantitative rigor of physics, VMT, and the qualitative insight of mathematics, TDA. As the next step, I plan to extend my radar geometry into a straining radar stress diagram that combines both the input stressors and the output strain. This will allow me to visualize how each stressor contributes to total deformation, energy, and how their interactions evolve over time. It also creates the foundation for applying topological data analysis, TDA, enabling me to detect transitions, bifurcations, or recovery patterns within my overall health system. Now that my radar geometry study is complete, I will move into the next stage, topological data analysis, TDA. My goal is to observe how the geometric shape of my health data evolves over time, not just the numerical values. Step 1. Dataset: I will use 6 variables, 5 input stressors, obesity, T2D, health, age, diet, and stress and sleep, and 1 output strain, cancer risk. Each biannual period represents 1 data point in a 6-dimensional space. Step 2. Geometric space: the 5 stressors define the coordinates, while the output strain serves as a dependent dimension or an abstract height. This setup allows me to study how the stress-strain relationship changes, and how the overall health system moves within this 6-dimensional space. Step 3. TDA construction: I will calculate Euclidean distances, the straight-line distances between all data points, representing different time periods in this multidimensional space, to measure their geometric similarity. These distances form the foundation for my TDA mapping, showing how different health states connect, merge, or separate through time. Step 4. Visualization: I will transform my radar charts into a continuous geometric surface, a topological health manifold. Points that stay close together indicate smooth and stable evolution, while branching or separated regions show transitions or bifurcations in my system behavior. The enclosed 3D curvature surface diagram below illustrates my topological health manifold. It shows a gradual reduction of strain energy over time, indicating continuous recovery and stable system behavior without major bifurcations. The attached diagram below shows my topological health manifold diagram. The left side, higher Z values, taller ridge, corresponds to my earlier years, roughly from Y90 to Y91 through from Y00 to Y01, representing the period of high strain energy and metabolic stress. The right side, lower, flatter region, represents my later years, around from Y24 to Y25, showing low strain energy, stabilization, and recovery. So visually, left is early years, unhealthy, high stress; right is recent years, healthy, stable. This left to right topological slope mirrors my cancer risk recovery trajectory, from a broad, high energy surface down to a smooth, low energy plateau, exactly as my 3 radar chats and my earlier VMT energy analysis results indicate. Step 5. Interpretation: smooth continuity means recovery and stability. Branching: a split into different health paths, or distortion, an uneven deformation of the system shape, means a major health change. Convergence means the system has regained balance and reached energy equilibrium. This process will extend my radar geometry into a true topological model, a visual map of how my body's internal system gradually released viscoplastic strain energy and moved toward long-term equilibrium. TDA observations: from my 18 biannual cancer risk dataset over the past 36-year, my TDA results reveal a single, continuous geometric pathway connecting the early high-risk years to the later low-risk stage. The early period, from Y90 to Y01, shows a broad and elevated surface dominated by T2D and diet stresses. The stepwise Euclidean distance, which measures geometric change between consecutive time points, peaks between from Y00 to Y01 and from Y02 to Y03, with continued adjustment through from Y04 to Y05. This interval represents the largest geometric change in my dataset, and marks the true turning point from cumulative stress toward recovery. The mapper-style topological graph, which represents the geometric connections among data clusters across time, confirms one smooth manifold, which represents a continuous geometric pathway of system evolution, without major branching, indicating that my health system evolved along a stable recovery path, rather than splitting into alternative outcomes. After from Y12 to Y13, the topological manifold curvature flattens, showing geometric stability and energy equilibrium among all 5 stressors, from the angle of my cancer risk probability. TDA conclusion: through this TDA study, I demonstrated that radar charts, when extended into a longitudinal geometric framework, can illustrate the evolution of health strain, such as my cancer risk, energy over time, the progressive shrinking of the radar polygons between from Y90 to Y91, from Y12 to Y13, and from Y24 to Y25, visually quantifies the cumulative stress release and recovery of my metabolic system. I deliberately selected 3 representative biannual periods, unhealthy, turning point, and healthy, to graphically illustrate my cancer risk study clearly and effectively, rather than presenting all 18 consecutive radar charts, which could be confusing. This TDA analysis further confirms that my metabolic and cancer risk system followed a smooth, single-path recovery trajectory. The curvature of the topological health manifold and the consistent contraction of the radar polygons both validate progressive viscoplastic energy release, which I presented earlier, structural realignment, and long-term stabilization, fully consistent with the predictions of my VMT energy model. This work confirms that a topological geometry is, in essence, a multidimensional radar chart evolving through time, if I stack them together, vertically, allowing me to study the shape, continuity, and energy dynamics of complex biological systems. Disclaimer: this content is provided for educational reference only, and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and related materials belong to the author, Gerald C.